Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about basic requirement for analysis. These are our team members. Introduction. This presentation explains the basic steps needed before doing chemical analysis. It includes how to take sample from solid, liquid, and gases, how to store them properly, and how to prepare them for testing. It is also covers how to make standard solution and the difference between primary and secondary standard. This step help to make sure that the result of the analysis are correct and reliable. Next, what do they mean by sampling? Sampling is act of collecting samples to produce meaningful information. Today, we will learn about sampling technique. First, the size of the bulk to be sampled. The second one is the physical state of the fraction to be analyzed, which is solid, liquid, or gases. Next, the third one is the chemistry of the material to be assayed, properties of the sample. Did you guys know that nothing can be done that would destroy or alter the identity or quantity of the analyte? Next, I am going to talk about sampling solid. Inhomogeneity of the material make the sampling of solid more difficult. The easiest way to sample a material is by grab sample, which is the sample is taken at random and assumed to be representative. For reliable results, it is best to take 1 over 50 to 1 per 100 of the total bulk. The larger the particle size, the larger the gross sample should be. The gross sample must be reduced in size to obtain a laboratory sample.
For the next one is example of tool for solid sampling. The first one is tablet sampler. It is designed to take a sample of tablets and capsules as containers are filled. The second one is scooper, a stainless steel scoop with a capacity of 5 oz 148 mil, perfect for sampling powder, solid gravel and other materials. For the third one is tubular sampler. It is for taking samples from soft and semi-solid materials. For the next one is sampling liquid. Number one is liquid samples are homogeneous and are much easier to sample. The second one, the gross sample can be relatively small. And the third one is if liquid samples are not homogeneous and have only small quantity, they can be shaken and sampled immediately. For the next one is example of tool for liquid sampling. It is a TIFF sampler. Next, we move to the sampling gas. Number one is it is tend to be homogeneous and large volume of samples is required because of their low density. For the second one is air analysis. Use a high vol sampler that is containing filters to collect particulates. And breath sample, it is the subject could blow into evacuated bag. And for the third one, liquid displacement method. The sample must has little solubility in the liquid and does not react with the liquid. These are the example of tool for gas sampling. Number one is high volume sampler, breath sampler, and liquid displacement method. Next, we move to the method of sampling, grab sampling. An actual sample of air is taken into a flask, bottle, bag, or suitable container. Second one is continuous or integrated sampling. Gas or vapor removed from the air over a measured time period and concentrated by passage through a solid or liquid sorbent.
Sample storage. Sample storage purpose, there is time gap between when the sample is taken and the actual analysis is being carried out. For liquid samples, make sure that it is kept in bottles with stoppers. Acidic liquid samples can be stored in glass containers, whereas basic liquid samples are in plastic container. Solid samples are easier to catch and have a less chance of being adulterated by foreign methods. Sometimes it can also get absorbed or adsorbed to the wall of the container. What do they mean by sample dissolution? Is the digestion or mineralization of a sample to render it soluble and to destroy organic matter that may interfere with the recovery of the analyte. Dissolution of sample drying agent. Advantage simplicity. Free from contamination since few or no reagents are added. For this disadvantage, volatilization of elements, losses of analyte by retention on the walls of the vessels. Absorbed metal on the vessel may in turn contaminate future samples. 2 to 4 hours are needed for drying aging. Long hour needed. Next is dissolution of sample while etching. Advantage and disadvantage. Advantage is superior in terms of rapidity. Freedom from loss of analyte by retention. For disadvantage, introduction of impurities from the reagent necessary for the reaction. Eliminating interference. Interference are substances that prevent direct measurement of the analyte and must be removed. May include separation step, precipitation, chromatography, distillation, dialysis, extraction into immiscible solvent. What do they mean by standard solution? A reagent solution of accurately known concentration is called a standard solution.
So now I will talking about a standard solution. A standard solution can be prepared in either of two ways. The first one is primary standard. It's carefully weighed, dissolved and diluted accurately to a known volume. Its concentration can be calculated from this data. Secondary standard, the solution is made to an approximate concentration and then standardized by titrating an accurately weighed quantity of a primary standard. Now, I will talk about the comparison between primary standard solution and secondary standard solution. For primary standard solution, the primary standard solutions are solutions made out of primary standard substances, while the secondary standard solution is solutions made specifically for a certain analysis. The second one, primary standard solution is extremely pure for about 99.9%. And the secondary standard solutions not very pure. Primary standard solution is less or not reactive at all, while the secondary standard solution is comparatively more reactive. Primary standard solution is not hygroscopic, while for the secondary standard solution, somewhat hygroscopic. Primary standard solution used to standardize secondary standards and other reagents, while the secondary standard solution used for specific analytical experiments. Examples of primary standard. The number of primary standards available is very limited. For example, oxalic acid, potassium hydrogen stylate, sodium carbonate, calcium carbonate, potassium dihydrogen phosphate, potassium hydrogen tartarate, sodium chloride, and arsenic chloride. I will talk about examples of secondary standard. The examples is HCl, HNO3, NaOH, KMnO4, and AgNO3. What do they mean by standardization? Standardization is a process to determine the concentration of a solution by titrating with the primary standard or with a solution of known concentration. Example 1. An approximate solution of 0.1 molar HCl was prepared by diluting the HCl stock solution. It was then standardized by titrating with 0.195 gram primary standard Na2CO3. The titration reaction is follow. Na2CO3 plus 2HCl is reversible with 2NaCl H2O plus CO2. The titration requires 36.1 ml of HCl. Calculate the molar concentration of HCl. The RMM for Na2CO3 is 105.99 gram per mole. For the solution, 2 mol HCl is equal to 1 mol Na2CO3. Then, mol Na2CO3 is equal to 0.1905 gram divided by 105.99 gram per mole. We got 0.00179 mol. So the mole for Na2CO3 is 0.00179 mole Na2CO3 times 2 mole of HCl divided by 1 mole Na2CO3, and all of that is divided by 36.10 milliliter over 1000 milliliter. So M for HCl is 0.09956 m. The conclusion is it's critical to comprehend the fundamentals of chemical analysis in order to guarantee correct and trustworthy outcomes for solids, liquids, and gases. Appropriate sampling techniques aid in the collection of a representative sample. Correct sample storage avoids contamination or alterations. The sample is prepared for testing by drying, dissolving, and eliminating interference. Making accurate measurements is aided by the use of primary and secondary standard solutions for any chemical analysis to produce reliable and valid results. Each of these procedures needs to be meticulously followed.